Hi, in this video, we are going to talk about binomial distribution. And before we get into the notes, you're going to need your calculator handy because we are going to learn a new button on the calculator. So we're just going to go ahead and start off with the calculator. And so what we're going to be talking about is combinations. And so the way you find combinations on your calculator has to do with probability. So you're going to hit the button that says probability on this calculator. It's over one, down one. So you hit probability, and then we're going to use the second choice, the one that says NCR. And so that would be the second choice right there. Now, in order to use that button, you need to type a number at the beginning and a number at the end. So for example, let me get out of here. Let me clear all this. If I want to do, let's just say I have a 5, and then I can go to probability, NCR, and then hit 3. Then the calculator is going to give me the answer of 10, which means my N is 5 and my R is 3. I know this doesn't make complete sense right now because I haven't really defined those variables for you, but I just wanted you to know where the button is on the calculator for when we do it in just a minute. So before we get to that problem, let's check it out on the graphing calculator. And so again, you want to be in probability, but for this group over here, graphing calculator folks, probability is under math. So you hit the math button, and then you can scroll along the top to probability. And once you get to probability, you'll notice the third one down is that NCR button. So just like in the last one, if I hit a 5, and then I hit math, scroll over to probability, go down, oopsies, wrong button. Let me try that one more time. Math, scroll over to probability, scroll down to NCR, and then I hit 3. So on this calculator, it just took the 5 and the 3. See that a little better. I have like literally the worst luck with calculators. Anyways, it doesn't matter if you can see it or not because you just need to know how to hit the right button. But the answer is 10. If you can see it on your calculator, great. It doesn't even do what it's doing on all calculators because some graphing calculators are older, some are newer. So anyways, as long as you know where that button is, you'll be able to do this. So let's go ahead and look at the notes, and that will show us what numbers we're going to be plugging in and how we're going to use that button. Okay, so we have binomial distribution. And what binomial distribution is, it allows us to deal with circumstances which belong to two outcomes. So common outcomes would be acceptable and defective, survived and died, true or false, yes or no, where there's two choices. If I said, I'm going to draw a card out of a deck of cards, and I'm going to record the suit, there's a lot of different suits. There's hearts, there's diamonds, there's clubs, there's spades. But if I said, I'm going to draw a card out of a deck of cards and I'm going to record whether or not it's a club, well, then I would say, yes, it's a club, or no, it's not a club. So yes and no are my only two answers. And so that would put it into two categories. So when it says binomial distribution, that's what we're talking about, two, with that prefix of bi. Okay, so some qualifications that we need for a binomial probability distribution. It has a fixed number of trials. So you have to be able to figure out what x equals. The fixed number of trials. How many trials does it have? That's not right. Sorry about that. It's n. N is the number of trials. N is always the number of things we're talking about. So n is the number of trials. The trials must be independent. So for example, going back to my cards, if I pull out a card and I say, is this a club, yes or no? Put the card back in, shuffle the deck. It doesn't matter what card I just drew. They all still have an equal chance. I pull one out. If it was not independent, what that would look like is I draw a card and then I throw it in the fire, and now I only have 52 cards, and I draw another card, throw that in the fire. It's gone. It's in the fire. So that affects the probability. We're not usually going to mess with that. Most of our stuff's going to be independent. Okay, each trial must have all outcomes classified as a success or as a failure, and we need to know which is which. for success and failure. I'm going to show you why when we get to the box below. And then the probability of success remains the same. So this probability of success is, let me highlight that. The probability of success is P. The probability of a failure is Q, which you see right here, the formula 1 minus P. So those will just be easy decimals to calculate on your calculator. The probability of a success has to be the same in all situations. So it'll be given to you, and then you can just calculate Q with 1 minus P. And then X, I didn't actually, I said N. N is the number of trials. We'll just put that in the box here. And then X is the number of successes. So N is how many you're doing altogether. X is the number of successes. Now, this whole thing right here, this whole fraction, we can avoid having to type that into a calculator by using the NCR button, the one that we just talked about, where N is N and R is X. Now, why is R X? Because I can't program everyone's calculator, right? Your calculator already came with an R, but the formula uses X. So we're going to plug the R in for the X, and then the rest of the formula will stay the same. So we're going to multiply this by P to the X, and then we'll multiply it by Q to the N minus X. Okay, we're going to practice that in another page. I'm not going to get too much on that right now. What I want to focus on right now is these rules right here, and then we'll come back to the formula. So right here it says, do the following procedures result in a binomial distribution? So we're asking 12 jurors whether there is a no response when they're asked if they've been convicted of a felony. And so looking at the list here, number 1, it has a fixed number of trials. Number 1 from the list above, N equals 12 because we're asking 12 jurors. So it's fixed. We know exactly how many people are being asked, so we're good to go. Yes. Number 2, the trials are independent. The outcome of an individual trial doesn't affect the probabilities of the others. So if you ask someone if they have been convicted of a felony, and then you ask the next person, because these are jurors, so there's 12 of them at a table. If you ask the next person, is their answer independent, or does their answer depend on the person next to them? So these are independent because each person's answer, yes or no, is only their own answer. It doesn't matter if the person next to them said yes or no. Their answer is only based off of their own history. So yes, it is independent. Number 3, each must have outcome classified as a success or failure. So the question is, have you been convicted of a felony? And we're writing down if it's no. So the answer to this question is either yes or no, which is 2 outcomes. So that's perfect. So you're looking, when it's asking about the number of outcomes, you're typically looking at the answer to whatever the question is. So how many people did we ask? We asked 12. Were their answers unique? Yes. What were the answers? They were yes or no. That's 2 choices. And then finally, the probability of a success. Well, 4 is just going to be yes, because each person has their own answer to this question. Each person is just as likely to say yes or no as the next person. If the probability was ever not the same, it would literally specify it. And so since there's nothing here that says anything skewed about the possibility, then we'll just say yes. So since these are all yeses, the final answer is yes, binomial distribution. Because that's what we're trying to find out. Is it a binomial distribution? Did it meet all 4? Yes, it did. Okay, question B, recording the number of children in 250 families. So number 1, is there a fixed number of trials? Can we say how many people answered? Yes, 250. Number 2, are the trials independent? If you ask one person how many kids are in their family, and then you go to the next row and ask them how many kids are in their family. Are they independent? Yes, they don't depend on each other. The dependent was like when I took out that card and I threw it in the fire and it changes the probability. That would be dependent. Most situations are independent unless you're removing something from the situation. All right, number 3. I already forgot. Each trial must have all outcomes classified as a success or failure. So are there 2 answers? Well, let's see. If it says the question is how many children are in your family, then the answer is either 0, 1, 2, 3, 4, 5, and so on. It could be any of those numbers. And so this is a problem because there's too many answers. We can only have 2. You can only have 2 outcomes. So if we change the question and it says, are there children in your family? Yes or no. That's different because that's giving you 2 choices only. But this, if you're saying how many children are in your family, everybody's going to have all kinds of answers. Some people are going to have the same as their neighbor. That's okay. Lots of people have 1 kid in their family or 2 kids in their family or something like that. But there's lots of different choices. It's not just limited to 2 choices. So I don't even have to check number 4 because it already failed. So this is not a binomial distribution. It's not binomial. It has more than 2 answers, and that's the problem. You really care about 1 and 3 because you need to be able to find n, and then you need to have your success and your failure in order to find P for success, probability of a failure, number of successes. See how those words are used there a lot? You need to be able to have that success and failure distinction in order to use the formula. Okay, so let's go to the next page and try this again. Oh, hope you can't hear my email. So it says, an adult is randomly selected. There's an 85% probability that this person knows what Twitter is. Suppose we want to find the probability that exactly 3 out of 5 randomly selected Twitters, whatever, adults, you can read, right? How many adults know about Twitter? Which, of course, isn't even called Twitter anymore, whatever. All right, so first of all, the big one is, do we know how many people, and can we find a success and a failure? So we know that 5 people were asked, so n equals 5. Is there a success or failure? Well, the question is, do you know about Twitter? The answers are yes or no. So yes, it is a binomial distribution. And so now we can find the values of n, x, p, and q. And now after we do this, we'll put it in the calculator. Okay, so n we said was 5 because there's 5 total people being asked. X is how many people were a success. So a success in this problem is knows about it. Because it says there's an 0.85 probability that this person knows what Twitter is. Suppose we know the probability that exactly 3 out of 5 know of Twitter. So if you know of Twitter, that's a success. So we want to know 3 out of the 5, 3 successes out of 5. All right, so since a probability means you know about Twitter, that means this is P because it says 0.85 knows about Twitter. And then to find Q, the formula is on the previous page, but you just do 1 minus P. Because remember from previous, actually just like the last section, the total probability adds up to 1. So if P is 0.85, Q must be 0.15 because together that adds up to 1. Okay, so we want to find the probability that exactly 3 people know about Twitter. I'm going to copy this formula so it's on this page, but it's this formula right here, the NCR P to the X, Q to the N minus X. I'll just put it over here real quick so we can see it on a couple problems. P to the X, Q to the N minus X. And really it says NCR, but that's where we're going to plug in the X value. So it's the NCR button on the calculator, but R is going to be where we plug in X. Okay, so this is what we're going to type in the calculator. We are going to type in N, which is 5, and then the NCR button, and then 3, because N comes first, and then R or X comes second. 5, NCR button 3, and we're going to do this all at once. We're going to hit times. P is 0.85 to the X power, which is 3, times, I'm just making them little stars so they're like dramatically bigger than decimal points. I guess I could use parentheses. Oh well. Times Q, which is 0.15, to the N minus X, the 5 minus 3 power. Now, some people can get messed up entering powers on their calculator. And so when it's simple like this, and most of the times it'll be pretty simple for the powers, I just do it in my head. 5 minus 3 is 2. So I'm just going to type 2 into my calculator. I'm not saying finding 0.15 squared is necessarily easy. I'm saying finding 5 minus 3 is easy. And so once I do 5 minus 3, then I go ahead and type 2 in my calculator. I was all trying to move my mouse at the same time. That's why I slowed down my speech. Okay, let me switch over to my calculator. Stop. And then I forgot to turn it back on. Okay, so in this problem, we said that it was going to be, oh, it's actually, we just did a problem just like this with the NCR. Oh, my cell phone is trying to help. Okay, so again, I'm just going to type this again so we remember how to do it. 5 first, and then the NCR button came from probability. Just go down to it. 5, NCR 3. I don't know why it says it so many times, but that's okay. Times P, which was 0.85, raised, which is this little, that little guy over there, little toggles, or not toggle, the little caret, raised to the 3rd power. Now, do you see how the blinker is up in the 3rd power? If I type times, the times is now up in the power. I don't want that. I'm going to delete that. And that little flashy thing is telling me hit over to make it big again. So then I can do times Q, and then I'm going to raise it to the 2nd power. If yours doesn't shoot up like that, that's fine. If it just shows this symbol, some of the older calculators just show that symbol. It's fine either way, as long as you have that times separate from the 3. All right, and then I hit enter, and I have 0.1382. Now with these probabilities, you typically round to 4 decimal places. Oh gosh, it was almost easier to see without my flashlight. Okay, anyways, I put it in my calculator and I got 0.1382. These probabilities, again, are typically rounded to 4 decimal places. Let me just get the right screen going. I don't want to do this mistake again. Voila, here we go. I think I lost myself in there somewhere. And nope, almost there. There I am. Okay, so again, 0.1382. So let's try this again. Problem 3, find the probability of getting exactly 2 girls when 3 babies are born. Okay, so we want N, X, P, and Q. N is the total number of babies, so there's 5 babies. X is, oops, I said it and I wrote it on the wrong one. It was N. X is the number of successes in this problem. They're saying girls is a success because that's what we're trying to find. What's the probability of having a girl? This is where people try to make stuff up. But we're just going with the basic. We're not getting too fancy into like, well, technically, certain women have a higher percentage. No, we don't care. We're going basic. It's statistics, not biology. So 50-50. 50-50 probability of a girl is a success. And then a boy would be a failure. Again, success and failure just means, does it answer the question? or is it the opposite answer? That's all we're saying here. Okay, so the probability of 2 girls is 5 NCR 2, because X is 2 in this example. And then I have 0.5 to the X power, so that's 2, because this is P right here. I'm writing it under on this one because P and Q are the same, so I want to make sure we get them separated. And this is to the 5 minus 2. So the reason it's 0.5 is because P and Q are the same. And just for exponent ease, calculator ease, I'm going to type a 3 in my exponent. So try this on your calculator. We have 5, and then we have NCR 2 this time. And then you hit times 0.5 to the second power times 0.5 to the third power, because we want the P and the Q represented. And this I did not have to round on. I'm getting exactly 0.3125. And it was exactly 4 decimal places. If you're not getting any of these, let me know, and we can set up a Zoom to get you going on your calculator. As a reminder, I said this once, I don't remember the last time I said this. I really know TIs and I really don't know other calculators. So sometimes it's faster to Google, but sometimes I can help too. Okay, so now we know when it's just straight up 3 people, 2 people, whatever, how to do the problem. This next problem says, find the probability. Oh, so this is talking about the Twitter thing, the 0.85 again. Find the probability of getting at least 3 adults when 5 are randomly selected. Okay, so what we have here, we can still do our N and our P and our Q because there's 5 adults total. Our probability of success, this is just like problem 1. The probability of success is 0.85. Not problem 1, the one on the top of the page. I think it was problem 2. And then Q, remember that came from 1 minus P. The difference between this and problem 1 is the word at least, or the phrase at least. And so here, X is at least 5. Remember, at least is tricky. Remember, at least is like you have to be at least 21 to go to a bar. You have to be at least 16 to drive. So at least 3 is greater than 3 or including 3. Because to drive, you have to be equal to 16 or greater than 16. To go to a bar, you have to be equal to 21 or you have to be greater than 21. So we have at least 3. So what that means in this example is that X equals either 3, 4, or 5. We have 3 different choices. That means we have 3 different problems. So we're going to do the probability of 3 and the probability of 4 and the probability of 5. And then we're going to add those answers up, and we're going to get our final answer. The good news is with your calculator, you can usually copy a lot of the work and not have to type it all in. Now, there's going to be completely different answers, but you shouldn't have to type everything in from scratch. All right, so the first one is 5 NCR 3. I feel like we already, but this is example 1, isn't it? Okay, we already did this one. I'll write it out anyways, but we'll copy our answer from above. And then we have P to the X power. X is 3 in this example. And let me just write out the X's so we know. Oh my gosh, who's emailing me while I'm making a video? That's X equals 3. This one's X equals 4, and that's X equals 5. That's what the 3, 4, 5 mean in the parentheses. Okay, so 0.85 to the X, and then 0.15 to the N minus X. And this answer, we already did this problem, 0.138. All right, next one, we want 5 NCR 4. So we're going to do the same problem, but this time instead of 3s, we're going to use 4s. So we have 0.85 to the 4 and 0.15 to to the 5 minus 4, which is 1. And I'll do that in a second. I just want to write out 5. And then we'll write it out. Then we'll do them in the calculator. Okay, 5. And then what's changing is the x is also 5. 0.815 to the 5. There's a lot of 5s in this problem. Times 0.15 to the 5 minus 5, which is 0. It's okay. We can have a 0 power. It's just it equals 1. But it doesn't matter if you know that or if you don't know that. All you have to know is it's okay, and we'll type it in the calculator. All right, so what's different on these problems? 3, 4, 5. 3, 4, 5. 3, 4, 5. That's what's different. So then when we type it into our calculator, that's what we're going to change. So going back, last time, I'll do it on my screen, and then after this, you can just let me know if you have any calculator questions, because I really hate showing you, only because it just never kind of comes out the way I want it to. Okay. So I'm going to go up to question 2, because it's in my calculator still. Question 2 is. My cell phone really tries to help out, but I swear it does more harm than good. Okay, we're just going to leave it like that. Light up over here. Okay, bear with me. So we have that, and I'm just going to hit enter, because that gives us the answer to the first part, which we already did. Okay, the second part, I'm going to go up again, highlight the problem I just did, hit enter, and now I'm going to change all of the things that change in this problem. So the 3 changes to a 4, the 3 changes to a 4, and then this power was 5 minus 4, so this becomes 1, and I hit enter, and I have my next answer, 0.3915. Yikes, my horses just went crazy, which means my dogs go crazy. 0.3915. I'm just writing it down, and then I know my screen didn't show. I'll show you in just a second. Okay, last but not least, let's copy this one more time. So we highlight the whole problem. We hit copy, and now we're changing all the 4s to 5. So I'm just using the arrow to switch over. 4 goes to a 5. 4 goes to a 5. And we just talked about this power. 5 minus 5 is 0. And voila, 0.4437. 0.4437. Okay, so I am going to switch my view back over so that you can see. And all I did since I was over on my calculator was I switched over, or I wrote down these 2 answers right here, which we just talked about from the calculator. So you already have them written down. Okay, so as a reminder, we said back at the beginning that we were going to add up all these values. So now that we have them, I'm going to add up these 3 numbers right here. I'm going to get rid of that circle just because it's ugly, but I just wanted you to see what I was adding. Okay, so I'm just going to type this in. We don't even need to see it, but I type in 0.1382, 0.3915, and 0.4437. I add those up together, and I got 0.9734 as my final answer. So you're walking down the street, just find 5 adults, and you ask them who knows about Twitter. There's a 0.9734 chance, a 97% chance that at least 3 of them, so either 3 of them, 4 of them, or even all 5 of them have heard of Twitter. Okay, enough about Twitter. Never, last one right here. Okay, sidebar. For some reason, Elon Musk thought I was a robot, so I got my Twitter deactivated. But I fought it, and I just got my Twitter reactivated. And this really isn't exciting because I don't even know how to use Twitter. I was just mad that Elon Musk thought I was a robot. So I'm back. Okay, or it's X, whatever. Maybe that's why he thinks I'm a robot, because I call it Twitter. Okay, who cares? Last problem. The difference between this one and the last one, or this one and the one before, is, and I even put it in bold, this one says at least 1 adult knows about Twitter. Okay, so before we get into that, everything else in this problem is the same. Before we get into that, let's talk about what at least 1 means. So you go up to a group of 5 people and you say, do you know about Twitter? Yes or no? Let's think about all the choices. Either nobody knows about Twitter, one person knows about Twitter, 2 people know about Twitter, 3 people know about Twitter, 4 people know about Twitter, or all 5 people know about Twitter. Those are the 6 possibilities. At least one, remember from before, at least 3 meant greater than or equal to 3. So at least 1 means greater than or equal to 1. So we need to find the probability that either 1, 2, 3, 4, or 5 people know about Twitter. That's a lot of steps. Look how many steps it took us on the last one. But there's a shortcut. At least 1, by definition, means, oopsies, that's not even how you spell 1. At least 1, by definition, means all but 0. All but 0. All right, look at this. Look at where I circled it over here. Or I put a red box around it. I put a box around 1, 2, 3, 4, 5. Everything except 0. At least 1 means all the answers except for 0. So how do we write all but 0 in math? Because that's English right now. So I'm going to write this sentence again, but in math. So at least 1, greater than or equal to 1 is at least 1, means, oops, yeah, I can write means. We don't need means in math. We can do means in English. 1, all the probabilities is 1, except means take away, and 0 means the probability of 0. So at least 1 means we could take everything, which is 1 whole, because all the probabilities added together equals 1 whole, and then we just take away the probability of 0, and we're left with at least 1. I wanted to show you something. This is in a different video, but if you have your notes all in order, it's probably just a page before. Oops, it was, nope. I know I just did it in a video like a week ago. It's probably the beginning of 4.1. I swear it's right here. Okay, here it is right here. Sorry, it was a little farther back than I thought. It's actually the first page of chapter 4. Okay, but that's okay. This is what I want to show you. We did this problem and we knew that the sum of all the, no, that doesn't say that. We knew that the sum of all the probabilities equaled 1. So if we had these first 4, which we said was equal to 98, like 98 cents, then we knew the last one was just 1 minus all of those. So it's the same idea. If we want these, oh, that was a terrible highlight job. Let's show that again. If we want everything except 0, I just have to do 1 minus everything that I have, and that will give me, vice versa. If I know what 0 is, then I know the rest of them added together are 1 minus that number. Does that help? Did that confuse you more? Okay, if that confused you, just rewind a couple seconds and forget I said anything. But maybe that helped like one person. Okay, so this is what we're going to do. We're going to find, or let's see, we're going to use, and because it's the same stinking Twitter example, n is the same. X is at least 1. P is 0.85. And Q, oh, sorry if I try to scroll up so that the closed caption, if you put closed caption on, you can read it. But this is not letting me scroll down anymore. Oh, I guess I just needed to try harder. Okay, there we go. Okay, at least 1. So the probability of at least 1 is the same thing as the probability, oopsie, sorry about that, as 1 minus the probability of 0. 1 is 1. What's the probability of 0? Well, the probability of 0 is n, and then the NCR button, and then 0. So for the probability of 0, we're going to use x equals 0. Remember, that's not the answer. That's what we're taking away to get the answer. 1 NCR 0 times our P to the X power. Remember, X is 0. And then Q times the 5 minus X power, 5 minus 0. Don't worry about a 0 power. Don't worry about 0 in this formula. And so we're going to just type, whoopsies. Oh yeah, let's figure out what that probability of at least, let's find out what the probability of 0 is, and then we can subtract it. So I'm going to type in, I'm typing in this part right here that I'm subtracting. 5 NCR 0 times 0.85 to the 0 power times 0.15 to the, now it says 5 minus 0 power. Does anybody know what 5 minus 0 is? Just kidding. I know you know what that is. So we get to the 5th power, and I got a really tiny number, 0.000076. I know I say round to the nearest 4, but this had so many zeros, I just went a little farther. And so now to finish this problem, I'm going to do 1 minus 0.000076, which is 0.999924. It's like a 99.99% chance that this person, that's at least one person knows about Twitter. So this number is super close to 1 because it's so likely that at least one person knows about Twitter. It's not very common to get a situation where like you have 5 people and none of them know about Twitter. And yeah, so this was, hopefully you're getting the hang of the new notation. A lot of this was just calculator, plug and chug, trial and error. So if you're having trouble with your calculator, then go ahead and send me an email. Let me know what's going on. Otherwise, I will see you in the next video. Bye.